Okay. Any questions from physics or anything that you have in the last class? You can also ask. So, is there any question for anybody? Any doubt from the physics class? Anything? We just started. If there is any doubt, you can ask. No doubt. So we go ahead with our first chapter. So our first chapter is named as matter in our surroundings. Okay, matter in our surroundings. So let's see, and let's have our discussions. Okay, the first word for our chapter here will be matter, and how we will go into this chapter, we will see our chronology. Matter. We need to know a little bit about matter. You have been reading from grade 6. Anyone would like to say anything about matter? What is matter? Oh, pura ekdam rattu definition. Anything that has mass and occupies space, matter. So why do we say you have no gray matter? What is gray matter? Gray matter means brain. हाँ, जिसके पास कोई अकल नहीं उसे हम क्या कहते हैं? There is no gray matter in you, right? So matter. Matter is, जैसे हम हिंदी में कहते हैं पदार्थ. It is anything that has mass. Means matter will have some sort of weight if you try to weigh it. And second comes, it also occupies space. This is what our friend Atreya has defined. Now let's try to classify. Let's look at my stylus pen. Does it have mass? Yes. Does it occupy space? Obviously, जहां पे रखूंगा उतना जगह तो खा लेगा. How about the air in this room? Does it occupy space? Does it have mass? Yes. But a difference है उस air और इसमें. What is the difference?
Density.
बहुत हाई लेवल में सोचते हो, बहुत हाई. नहीं बाबा, इसको देख सकते हैं, उसको देख नहीं सकते हैं. मैटर बोलने से हमें फील होता है something that we can see. The beautiful face of Atreya, I can see. Yes or no? But the cruel intentions behind, I can't see. That is feeling, that is not matter. So I always say that when you define matter with these two, try to add one more, something. इससे हम एयर को भी डिफाइन कर देते हैं. Something that can also, yes, very good, also be felt. देखो, the first two can classify anything like your head, your pen, or anything. But if when you talk about air, air does have a mass. Air does occupy space, but that feeling nahi aata hai because we are unable to see it, right? So if we say that something that can be felt, so yes, this is the classical definition of matter.
Yes, we are being blown by
Hmm.
we
We do feel air. So air is also matter. You don't see. Why did I write this? This is one additional. These are all characteristics of matter. They don't define matter. They are something that are adding to the characteristics. We are talking about a characteristic that matter must have mass in it. Let's say you take a black forest cake. Does it have mass? Yes. Does it occupy space? Yes. Can you feel it? Obviously, on a birthday, when I smash it on your face, you can feel it. But when it comes to air, you don't see it. So if I include this word of feeling, then I think the definition becomes very wholesome. Matter is something that occupies space, that has got mass, and that can be felt. Clear हुआ है? Okay. ये chapter जैसे जैसे हम आगे पढ़ते हैं, so matter के बारे में तो a lot of stories, like we only think about the Greeks and all. In Indians have done, our Rishi Maharishis have spoken about this centuries and centuries ago. जैसे पदार्थ होता था, अणु है, परमाणु है, like the atoms and molecules. These concepts were given by Indians long back. So the first thing that comes up is that matter in the going stages, how will we study matter? आगे जाके हम पढ़ेंगे that matter can be studied for the physical properties, okay, the physical, and for the chemical properties. This will be our roadmap. Chemical properties. When we talk about the physical properties, these are the properties, okay, the properties of matter. Properties. So when we talk about properties, physical properties में matter को usually solid, liquid and gas में classify किया गया, and that is what is the later course of the chapter. And when we talk about chemical properties, we'll be talking about elements, compounds, and something called mixtures. At this chapter, we will not be diving here at all. This is something which we will take up in chapter number 2. So our first chapter would be dealing everything about matter, understanding facets of matter and certain properties of matter. Thereby we will be going on solid liquid gases, and we will study properties around solid liquid gas state of matter. Have you understood? ये है हमारा chronology जाएगा. Now matter is said to be, matter is composed of tiny particles. और एक grandma story जैसा है, chemistry is the literature of science. Tiny particles. At this stage, do not break your head to understand whether these particles are atoms or molecules. We are only saying matter is composed of very tiny particles. Even if you think of atoms, how does atoms come? The atom concept comes from a Greek, philosopher or a scientist. Those days we used to say philosophers. So his name was Democritus. What did Democritus do? He took an apple and he started slicing it. फिर दिमाग में खुराफाती ख्याल आया, स्लाइस करते 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 सबसे छोटा स्लाइस क्या होगा? What is the smallest portion that I can go on? And then he conceptualized, he said that the smallest portion that we can go on is something called atomos. और वो atomos से ही atoms word आता है. छोटा करते जाओ, there should be some, right, some entity. And those days we did not know what is atom, proton, and these are all BC, centuries ago. So it is accredited to Democritus by all the books that were published from the West. But Maharishi Kannad from India gave the concept of Anu and Parmanu much, much before that. Aryabhat's calculation of pi is very correct. 0 was given by Indians. Sushruta is an Indian sage who did surgery in centuries ago using anesthesia. लेकिन हमारी बातें बाहर नहीं जाती हैं, right? So we say matter is composed of tiny particles. अब ये study हम करने वाले हैं. Who tells you that matter is composed of tiny particles? There will be two concepts that we will study. One is known as the concept of diffusion, and the next one is known as Brownian motion. Displacement is in physics. कुछ भी ले आता है. Brownian motion and diffusion, all new words for you. So what is the story, children? We are studying about matter. Matter is composed with very small particles. This is a statement. And as studying science, we are not supposed to just believe something that is imposed on us. We have to have solid proof that is matter composed of particles or not. To approach to this theory, we will take the help of two aspects or phenomenon, as we call. One of the phenomenon being diffusion and one of the phenomenon being Brownian motion. Okay, so let's little bit first understand diffusion and see how diffusion helps us to understand. पहले आंख बंद करके कौवे की तरह लिखते मत रहो. पहले सोचो, what are you trying to hunt in grade 9? That what are we trying to hunt? Matter is composed of particles. We are trying to vouch for this statement, and we will vouch this statement from two aspects. One is diffusion. तो diffusion से हम ये conclude करेंगे, Brownian motion से भी ये conclude करना चाहिए, है ना? Ultimately इसी में आना है. तो थोड़ी देर के लिए diffusion में बात करते हैं. What is diffusion all about? So diffusion का best example है हमारा तेगबीर. जब भी वो बढ़िया बढ़िया परफ्यूम लगा के आता है तो हमारे नाक में कैसे आ जाता है? Obviously he did not put or spray the perfume in my house. Did he put it in this flat? No, he had sprayed the perfume in his flat. How is that when he entered this room, after some time I say, perfume डाले हो ना? अच्छा, एक और example लेते हैं. Right now, which flat we are in? 1303. अगर 1203, जो कि मेरे नीचे वाला फ्लैट, बिरयानी बनाना शुरू करे, क्या मुझे खुशबू आएगी? Yes, it comes. And after some time, when, let's say, we'll go back to a previous example, when Tegbir enters my flat, immediately I say, did you spray some perfume today? He says yes. फिर वो जैसे ही घुल मिल जाता है 5-10 मिनट, then no more I'm not smelling that perfume anymore. But after that, if Atreya gets into the house suddenly and he says, कोई perfume लगाया है क्या? Don't you see, this is very common. If, say, suppose I have cooked biryani in my house right now, and you enter, you'll say, sir, did you make biryani? Very nice aroma going on. And after some time, you're fine. आप कुछ नहीं पूछते हो. Again, a new person comes, he again says, did you make biryani? इसका मतलब है that there is something where there is a zone of richness, that is the aroma of biryani, and there is a zone which is not rich, that may be my nostrils. And when my nostrils comes into this zone, there is inflow of something. A smell of biryani comes. And after that, I don't talk about it, means some sort of equilibrium gets achieved. When the smell of biryani is no more new to me now in this house. But when a new person comes in, again for him, there is a little bit of Amiri and Garibs. So let's put that into science. Okay, इस diffusion को science के main में देखते हैं. So diffusion में क्या होता है? Diffusion में we will always have a region difference. A region. What is the region? We call the region of high concentration, and the region of low concentration. Children, पूरा आराम से समझिए इस चीज को. Low concentration and high concentration. Take the example of Takebir putting perfume on his body. Then the area and zone around him that is walking, the air around him, is in high concentration of that particular aroma. And he came to my house does not have that perfume. For that perfume, I'm in low concentration zone. Diffusion में क्या होता है? Particles will always move from high concentration से move करना शुरू करेगा low concentration में. कब तक? जब तक एक equilibrium नहीं हो जाता है. And once that equilibrium is established, now the area around my nostril has also become in equilibrium with the zone around the air that is carrying around his body. So I don't feel any more new smell or the smell. But when say Samar enters his house, he's again a low concentration region. एक और एग्जांपल लो. किसी के घर में पूजा हो रहा है और समथिंग अगरबत्ती जला दिया है. अगरबत्ती वहां जलता है तो यहां तक स्मेल आता है. हैव यू स्मेल्ड अ रॉटन रैट? लिजर्ड मरने का स्मेल लिया है? तुम लोगों ने लाइफ में कुछ अच्छा सूंघा ही नहीं है. लिजर्ड जब मरता है कितना बढ़िया खुशबू होता है ना. So how is it coming? That lizard's death zone area is the high concentration zone. और पूरा घर कैसा है? लो. अच्छा, very common example that you see in flats is दूध का जलना. आपके ऊपर या नीचे फ्लैट में somebody दूध का जलना तो आपने देखा होगा ना. ये फ्लेम बढ़ा दिया, the entire milk spills over, and after that burnt milk has got a very smell which it can't escape your nose. So where the burning happened, that was the region of high concentration. So have you understood diffusion? Diffusion is, now how do we define diffusion? Diffusion, I will say, is the movement of particles. And how do the particles move? It's the movement of particles from region of high concentration towards region of. अगर आप उल्टा करने की कोशिश करते हो ना, then that is called reverse osmosis. वो जो आरओ बोलते हैं ना, आरओ वाटर प्लांट, आरओ में उल्टा करते हैं हम लो कॉन्सेंट्रेशन से. ये प्राकृतिक है. जहां यू वांट टू गो अगेंस्ट द नेचर, यू हैव टू पे सम मनी. अगर मैं ऐसा हो सकता है जैसे वीडियो रिकॉर्डिंग में टॉम एंड जेरी में दिखाता है ना, सारा स्मेल वापस चला गया फ्रिज के अंदर. दैट हैपेंस ओनली इन टॉम एंड जेरी, डजंट हैपन इन रियल वर्ल्ड. Can you take all the aroma and put it back into the biryani? No, that is not possible. So diffusion में it is always the movement of particles from regions of low concentration to region of high concentration. Tell me children, why did we learn diffusion? We learned diffusion because we need to understand diffusion in order to go back and support that theory that matter is composed of. अभी ये prove नहीं हुआ है. अभी हमने सिर्फ इसको प्रूव करने के लिए एक स्क्रू ड्राइवर लिया है और एक स्पैनर लिया है. We just understood what is screwdriver all about. Clear? स्पैनर को बाद में पढ़ेंगे. Brownian motion. So let's now take, is everyone okay? Examples of diffusion: lovely cooked food which is downstairs, or when you're crossing across a cow or a buffalo which has just given fresh dung and you smell that. मेरे examples तो ऐसे ही होते हैं. Then that is also diffusion. आपके नाक में आ रहा है ना? चीटी का क्या, छिपकली का मरना, lovely smell that comes up. Has anybody smelled a rotten potato? Yes, very common. If you have too much potatoes, it will happen in this season. You'll see the potato giving froth out. White color का froth देगा, and it will be similar to a lizard, death of a lizard. But if you won't be able to find out, that rotten potato will be hidden somewhere. जैसे ही निकालोगे ना, इतना बदबू होता है, आप उसको ऐसे लेके फेंकोगे. Diffusion. Clear diffusion? चलिए. अब डिफ्यूजन से एक एक्सपेरिमेंट करेंगे जिससे हमें पता चलेगा क्या, मैटर इज कंपोज्ड ऑफ पार्टिकल्स. ओके, सो लेट्स सी दैट एक्सपेरिमेंट एंड व्हाट ऑल वी आर गोइंग टू डू. सो व्हाट वी We take a beaker and we fill this beaker with water. Now Vakul will ask, sir, this is RO water or mineral water? Clear water. Clear water. How many of you have heard about potassium permanganate? Potassium permanganate is a purple color crystal which is used for cleaning water. If you go to your ancestral house or anywhere where you have your own water tank, then you'll see people always put potassium permanganate because it kills, it's a sort of a disinfectant. Yeah. Yeah, they will put a foot bath and all. Yes. ये इसको सब पता है. ठीक है? So let's see, let's now take a potassium permanganate crystal. So I take a potassium permanganate crystal. This is a potassium permanganate crystal and I keep it here. Right? And potassium permanganate, potassium permanganate crystal. If you are interested in chemistry, anyways, next year क्या आ जाएगा? Its molecular form, chemical formula is KMnO4. So it contains potassium, it contains manganese, it also has oxygen. And what is this? This is water. And this is my tumbler, or you can say a beaker. This is my beaker. Now what do we observe? We will slowly observe. What are our observations will be? Our observations would be something like this. Observations. Kaisa observation hoga? Number one, we will see that the crystal starts to dissolve. धीरे धीरे क्रिस्टल टूटना शुरू करेगा, टक 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 करके डिसॉल्व करना शुरू करेगा. And how will it dissolve? Fragments from the crystal will break out. So we will have small fragments breaking out from the crystal. Okay, crystal starts to dissolve and the water starts to get pink in color. The water starts to get pink in color. Is anything Greek and Latin out at this stage? Anyone? Harshit, Hannah, Aditi, this much, are you fine till this much? The crystal slowly starts disintegrating. And why did I take KMnO4? The very reason that KMnO4 is colored, so that you can see the activity with your naked eye. Okay, the crystal starts disintegrating and the water starts to get pink in color. Then, like that YouTube videos, they say 10 minutes later, 1 hour later. So after some time, what we see that the entire water has now turned pink. The entire water has now turned pink, and along with it, another thing we will see, that is number 4, crystal has dissolved completely. Crystal has dissolved completely. तेलुगु में बोले तो आई पिंड चला गया, किधर है, कहाँ गया crystal? Where did the crystal go? Dissolved in the water. We don't expect Vakul to go and pluck out the crystal out from there, right? So dissolved in water. And till the time you all write, so the beaker is now fully pink in color. Anyone has any doubt for this observation and experiment so far? Very pretty evident that the water has become now completely pink in color. Now let us put our story a little bit. What was here? This was water. Is this not matter? Yes, this is matter. Is this not matter? Yes, this is matter. And you all know matter can neither be created nor be destroyed. तो matter गया कहाँ? हमारी आंखों में तो इतना बड़ा दिख रहा था, अब गायब हो गया. लेकिन एक चेंज भी हुआ है. What is the change? The water which was clear in color now has become pink. Now we start weaving our story that there must be particles of either matter. Now how the particles were, अब हमारा यहाँ से now starts our explanation. And what is the explanation that we are going to have? Our explanation says that there must be KMnO4 particles which are pink in color, and there must also be what? Water particles which are colorless. These are water particles. ठीक है? दोनों को मैं ऐसे लिख लेता हूं ताकि आपको समझ में आ जाए. आई एम राइटिंग दिस एज के. ओके, पोटेशियम परमैंगनेट बहुत बड़ा हो जाएगा तो मैंने यहाँ पे KMnO4 लिखा और यहाँ पे ये वाटर है. वाटर इज H2O. Water is H2O, so I'm writing H2O, and these are all particles. Particles from the potassium permanganate crystal got dissolved. Got dissolved is an English word, but what happened in chemistry? Chemistry में अगर इसको देखा जाए यहाँ पे something जैसे मूवी में कहते हैं ना, और फिर शायद कुछ ऐसा हुआ होगा. There must have been water particles. Children, this is a very, very magnified image of a sample from here that I am trying to show you. बहुत ही बड़ा magnified image देख रहे हैं, small sample का. And there will also be some potassium permanganate particles. कौन बड़ा है, कौन छोटा है, at this level we can't say. But all we can say that since the water was in liquid state, so there was water particles, and the potassium permanganate particles happily went and dissolved, or rather say got mixed and occupied spaces between the water particles. This is what happened. Right? Question arises. Are these particles visible to you? No. That's why we had the statement. क्या statement था हमारा, जरा देखो तो. Matter is composed of tiny, adjective लगाया था यहाँ पे. Tiny particles. The matter is composed of tiny particles. These particles are not to be seen by us. But this proves that there has to be particle. Particle नहीं होगा तो एक जगह से दूसरे जगह रंग गया कैसे? Just try to understand. यहां से रंग यहां गया कैसे? How did the color go till here? Someone must have carried the color. Actually, this gives you two things. Not only are there particles, there must be some motion also in the particles. Do you agree? Otherwise, सारे particles बिखर के यहीं पे तो होना चाहिए था. पूरा चीज evenly pink क्यों हो गया? गैप हो जो हो, वाटर भी मूव किया कि हमें वाटर तो पहले से ही था. हम तो वाटर के कलर दिखाई नहीं दे रहा. I can see the pink color. If all the pink colors would have disintegrated into particles, I should have seen a dense lump of pink out here, but no, the pink has evenly mixed all across the beaker. That means there are particles in matter. Potassium permanganate is matter. Matter is composed of particles which are tiny, and I can't see them, but I can see the impact of it. So it consists of tiny particles, and not only does it consist of tiny particles, those particles must also be in motion. Otherwise, who took them here? My simple question is, who took them here? Kinetic energy. So motion तो रहना पड़ेगा ना. Kinetic energy means who has kinetic energy, beta? A body who has motion only has kinetic energy. So ये experiment समझ में आया. We took potassium permanganate. So what type of questions you can get from here is that they might elaborate this scenario in a competency-based question, and they might say, what are the inferences that you draw from here? The inferences, we say potassium permanganate being matter is composed of particles. The particles of potassium permanganate started to move and evenly mix within the space of the water particles. As a result, you saw this coloration. And this makes you infer two things. Matter is composed of particles, and matter particles are also in motion. So are we in a position now, children, to write our inference based on these two findings? So let's, chemistry में हम क्या कहते हैं बेटा? Inference कहते हैं. Inference. Inference is what is your conclusion? Inference. And this inference is based on KMnO4 in H2O. This was our first experiment. KMnO4 in H2O. And इसमें हम क्या use कर रहे हैं? We are using the concept of, अभी ये भी तो बात करना है. We didn't talk about that. Diffusion. How are you saying diffusion happened? How are you saying diffusion happened? There was a region of high concentration, and particles moved from region of high concentration to low concentration. This was steak beer with lot of perfume, and this was the area which was aroma denied or lack of aroma. So the aroma has spread across. Makes it clear? So I write now, I write here KMnO4 in H2O. This was my first example using diffusion. I say two findings: that matter is composed of tiny particles. अभी हम उसे atom या molecule नहीं बोल रहे हैं. We're just saying tiny particles, and particles of matter are in motion. Any child, strategic timeout of 1 minute, any child has any questions at this level can ask. Weaving the story back, we started with a statement that matter is composed of tiny particles, and we wanted to vouch for that statement. To vouch for that statement, we said that we will understand two concepts. What are the two concepts? One concept being diffusion and another concept being Brownian motion. We have not yet touched Brownian motion. So we started to understand first what is diffusion. Diffusion is a phenomenon in which there is movement of particles from region of high concentration to low concentration. Can you give some example? The aroma of cooking that spread across, or the fragrance of an incense stick or a burning agarbatti that gives you, that is aroma, or perfume. These are all known to be examples of diffusion. So what we did, we took a beaker with clear water, which was actually colorless, and we dropped a crystal of KMnO4 in it. Slowly we found that the KMnO4 crystal disintegrated, dissolved, and the entire beaker became pink in color. We could not find any trace of KMnO4 in particle nature. Any trace of KMnO4 in, not particle means which is visible from our eye, no lump, no granule or anything was seen. What do we conclude? We conclude that this has disintegrated into small particles, which are no more visible by my naked eye, not even maybe say a microscope also. And they have gone and they have occupied spaces within particles of another matter, and the another matter is water. Clear? The another matter is water. So and so that they must also be in motion. Otherwise, how did they mix throughout the beaker? Are we clear? Yeah, please.
Carrier of this fluid.
Yeah, very nice question. So our friend is asking us, when KMnO4 disintegrated into water, who was the carrier? Was it blue dart or was it DTDC? Somebody must have taken them. So now it depends is that the motion of particles will also vary. Some particles motion might be more, some particles motion might be less. And that's what we say. If you say that there is a child who keeps running around the house any now and then, so what do we say? The child is less energy or more energy? More energy. Similarly, she pointed out in the talk, Bhavya said that kinetic energy, this is what we are going to reveal slowly. These chapters are going to, these sections are going to be revealed. These particles must possess something called kinetic energy. Is my kinetic energy same with her? No, not necessarily. Your kinetic energy and another child's kinetic energy may be different. So the particle which has evenly moved across must be bearing more kinetic energy than the other particle. Or else we can say in another way also, that there must be more gaps between the liquid particle. As a result, the solid particles, who was solid here? KMnO4, they started and going, occupying the spaces between them. Slowly we will see more story, much more findings. So as of now, let us just restrict that the particles were in motion, and due to their motion, where are you in motion? You can be in motion only when you are pushed externally or you have energy on your own. They must be having their energy on their own, because we did not do any sort of stirring, we did not blow any air, or we did not do any sort of whipping or anything. So there was motion within them. आगे देखें एक और example. Now we are going to see the impact of what we call Brownian motion. Brownian motion. Nothing great. This was actually, term was given by Robert Brown. If in those days Vakul was alive, he would have said Vakulian motion. There's nothing great about Brownian motion. Brownian motion is said to be a zigzag random motion. Zig-zag, a random motion. A random motion. Zigzag random motion. How do we see Brownian motion? Oh, we are best because we get up very late. We get up at 10 o'clock from our bed and the AC runs till then, and the whole room, the curtains are pulled up. So a narrow strand of sunlight enters my room And then I get up from the bed because I'm the prince or the princess. Mama or our maid comes and she just dusts the blanket. At that time, do you see some dust particles moving like this and that? That is Brownian motion. एक तीर से मैंने दो शिकार किया. One was to give you a satiric cut that wake up early. You're in grade 9. And second, you also understood what is Brownian motion. Have you gone to a movie theater and you see the projector beam which is falling on the screen? And if you see on that projector beam, you will see some dust particles moving. There is no defined motion. कोई इस तरफ जा रहा है, कोई इस तरफ जा रहा है. And the best way to understand Brownian motion is take one cement ka boda where construction is going on and make your best friend stand beside it. Take a stick and start hitting that sack of cement. Everything will come out and that fellow will start sneezing. And that's Brownian motion. So how do we apply Brownian motion here? So we take something called pollen. Do you know what is pollen? What is pollen? Oh, pollen dust. So making some sort of a lovely jasmine flower. Okay. This is jasmine flower is actually given by Vakul to someone. Maybe Champakali, we don't know. So this has got pollens. ये जो particles है ना, इन्हें हम pollens कहते हैं. This is called pollens. So you take some pollens and you can take something known as a petri dish. So petri dish means the easiest way to understand petri dish is all you people invite guests at your home. So you have those glass flat rectangular trays. Have you seen which goes inside a microwave also? You put paneer or something. So in a chemistry lab, we have got similar sort of tray which we call as a petri dish. Okay. आगे हमें देखने घुसने से आपको दिखेंगे. Take 3. So in petri dish, you fill this petri dish with water. Okay, you fill this petri dish with water and take some pollens from where? From Vakul's flower. Okay, so that his heart gets broken and put those pollens out here. All right. Now the next diagram that I'm trying to make is the view that you will see from the top. The view that you will see from the top. So from the top, I'm seeing like this. This is the view from the top. Are you understanding? I'm trying to see from the top. So from top, what do I see? I see those pollens, and those pollens are like this, say in this manner. So if you observe, every pollen will be having a motion something like this. ऐसे कहीं जा रहा है, फिर कहीं ऐसे जा रहा है, ऐसे जा रहा है, कहीं ऐसे जा रहा है, ये ऐसे जा रहा है. हाँ हाँ, वैसे पोलन तो मूव करते जा रहा है. If you take pollens and drop those granules or pollens on this particular body, pollen क्यों लिया? So that I can have a very something which is near to a particle, but still visible with my eyes, right? Here we are trying to certify the motion perspective. So I took pollens which are very, very light yet visible to my eyes. And I sprinkle those pollens on water. And if I pick up one particular pollen, you will not be able to keep an eye on one pollen because the pollens are continuously यूं कुछ भी घूम रहा है. Question is, इनको कौन घुमा रहा है? Who is making them move? So now, yes, very good. The question comes, what are the two particles out here? जरा मुझे बताओ तो. We have pollen. Okay. So this is also a form of matter. Do you agree? And there was also water in the petri dish, which is also matter. While this matter was tiny, you could not see the water particles because the water particles are very small. And these water particles were the fast moving particles. And these fast moving particles are continuously colliding. So we say that the H2O particles collide continuously with the pollens. And this phenomenon is only giving rise to the Brownian motion. वही dust के वही projector beam में भी हो रहा होगा. Some particles, that dust is comprising of so many different type of particles. Some particle which is not visible with your eye must be hitting the other particle. So now combine the two stories together. Diffusion told me that particles do show movement, and particles can be as small as tiny, which you could not see with your eyes, yet you saw their impact, that they changed what? Clear water to pink. And Brownian motion tells you that the particles are in continuous motion. Even the previous example also tells me that they are in motion, but there maybe your heart did not agree that much because you felt that दिखाई तो नहीं दिया, यहां तो दिखाई दे रहा है तुम्हें, तुम्हें पोलन्स एकदम स्नूकर बॉल की तरह वी 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 हिल रहे दिखाई देंगे. कौन हिला रहा है इन्हें? Water particles. So children, have you understood what we are trying to vouch? I think we have been able to vouch now. Matter is composed of tiny particles. We have vouched it. How did we vouch it, or how did you prove it? You proved it to two phenomena, one being diffusion and one being Brownian motion. So what are the type of concepts on which we can be questioned till so far? People may ask us question on diffusion, Brownian motion. People may ask us pollen and water लेके question पूछ सकते हैं, KMnO4 and water लेके पूछ सकता है, मैटर इज कंपोज्ड ऑफ टाइनी पार्टिकल्स लेके पूछ सकते हैं. चलिए एक सुंदर सा एग्जांपल और देख लेते हैं. ठीक है, लेट्स सी वन मोर एग्जांपल. लेट्स ट्राई टू डिसॉल्व sugar in water. Wow, sugar in water. If you drop sugar in water, don't stir it. आप कुछ मत करो, छोड़ दो. एक दो घंटा बाद आके देखो तो चीनी कहाँ गया, चीनी कुठे गेला, मला माहित नाही, किधर गया चीनी. एंटायर चीनी हैज गॉन. कोई खा गया क्या? कोई नहीं खाया. आप थोड़ा टेस्ट करके देखिए, पानी मीठा हो चुका है. शुगर इज द मैटर. शुगर पार्टिकल्स डिसॉल्व इन व्हाट? वाटर पार्टिकल्स. ये पूरा कहानी से हम कुछ और कंक्लूजन भी ड्रॉ करेंगे. आइए, ये बड़े इंपॉर्टेंट कंक्लूजन है. नंबर 1, मैटर, बार बार लिखिए, इज कंपोज्ड ऑफ टाइनी पार्टिकल्स. ये सुल्तान मूवी देखा है आपने? सुल्तान में सुल्तान का जो स्पॉन्सर होता है ना, कुकरेजा कुकर्स, उसके बेटे का नाम होता है टाइनी. आई जस्ट रिमेंबर्ड. Sultan gets a sponsor, na? Kukrija Cookers. Have you seen that? That pressure cooker company. That fat boy's name is Tiny. Matter is composed of tiny particles. Particles of matter are in continuous motion. और ये कहां से पता चला? ब्राउनियन मोशन आपको ये और अच्छे से देता है, कंटिन्यूअस मोशन में है. अगर हम देखें तो ब्राउनियन मोशन से हमें ये पता चलता है. मैटर इज कंपोज्ड ऑफ टाइनी पार्टिकल्स, ये हमें डिफ्यूजन से पता चलता है. एक और एग्जांपल लेंगे, ठीक है? अच्छा, एक और एग्जांपल लेते हैं. लेट्स टॉक अबाउट समथिंग कॉल्ड एन एलिमेंट. ये एक एलिमेंट है, जान के रखिए, ब्रोमीन, और somebody calls this bromine. Okay, children, if you look at the periodic table, we have got some 104 elements. And in those 104 elements, 104 के आसपास elements है, there are only 2 liquids. Now this has no connection with your this chapter. This is general knowledge. There are only 2 liquids. One liquid was gifted to the non-metal family. Non-metal मतलब समझते हो तो, जिसको मारने से टंग टुंग आवाज नहीं होता है. And one was given. Out of this, one went here, 1 of 2, and the other, the 2 by 2, went to the metal family. And the metal family is known as mercury. Mercury is liquid at room temperature. Mercury and bromine are the only 2. Out of all these, there are only 2 liquids, mercury and bromine. Bromine जो है usually gas है, पर रूम टेम्परेचर में लिक्विड रहता है, फटाक से गैस हो जाता है. ब्रोमीन को गैस में भी देखा जाता है, लिक्विड में भी, याद रखिए. एंड ब्रोमीन का कलर कैसा होगा? ब्रोमीन इज ऑलवेज रेडिश ब्राउन. रस्ट देखा है आपने? रस्ट, रस्ट को पेस्ट करके पानी में घोल दीजिए, जो कलर होगा वही ब्रोमीन का कलर है. सो व्हाट डिड वी डू? वी टुक वन दिस सॉर्ट ऑफ अ, व्हाट डू यू कॉल अ, मेजरिंग सिलेंडर लिया, और एक और ऐसे, इसको इन्वर्टेड मेजरिंग सिलेंडर है, और बॉटम में एक और सिलेंडर लिया. ओके, और बॉटम वाले सिलेंडर को व्हाट वी डिड, वी स्टार्टेड, वी एक्चुअली फिल्ड इट विथ say bromine particles. How do I show bromine? There's no brown color. Okay, fine, I'm using pink only, sorry. So we filled it with bromine gas. This is bromine gas. इसको bromine gas डाल दिया. Because you would say otherwise, sir, you only showed the example of KMnO4 in water, that is solid in water, sugar in water, which is solid in water. Let's look about gases. Diffusion gases में भी होता है. This diffusion also happens. So this is what? Bromine. Bromine, we took it in a cylinder. So the cylinder is what in color? Reddish brown. Okay. The color of the cylinder is a reddish brown. This is a reddish brown.
लिक्विड फॉर्म में रहेगा क्या?
बोलो बेटा.
लिक्विड फॉर्म में रहेगा गैस?
ब्रोमीन लिक्विड है, रूम टेम्परेचर में थोड़ा टेम्परेचर बढ़ाने से गैस हो जाता है, तो ये गैस है, ब्रोमीन गैस. और मैंने खाली सिलेंडर लिया, एम्प्टी सिलेंडर, पर एम्प्टी होगा क्या? हम तो अर्थ में है, सिलेंडर हैज गॉट वाटर, सॉरी एयर. मैंने मुंह खोला, अंदर तो एयर है, देख नहीं सकते हैं. सो दैट सिलेंडर आई जस्ट डिड इन्वर्ट कर दिया इसके ऊपर, इन्वर्टेड, एंड दिस कंटेन्स व्हाट? एयर. सो सेम थिंग, यूट्यूब जैसा. 10 minutes later क्या दिखाई देगा? All the bromine particles will now start moving, और पूरा आपका जो ये है ना चेम्बर, ये पूरा ही रेडिश ब्राउन हो जाएगा. Another classic case of diffusion. This is a case of diffusion of gas in gas. Gas in gas diffusion. इससे पहले आपने क्या diffusion देखा था? Solid in liquid. Solid in solid diffusion होता है. कहाँ होता है? Very rare example, but if you have observed, your teacher writes on whiteboard or on blackboard in your school? Blackboard. So go to schools, you're studying in very costly schools. You have to go to schools like ours, which were like where the blackboard will be where I have studied, my sister has also studied, it has never got painted. So when they write with chalk on those blackboards, what happens? You know, after keeping on writing years and years, there will be small pieces of chalk which will diffuse into the blackboard. और टीचर जब डस्टर से रब भी कर रहा है ना, वो नहीं निकलेगा, और आप नाखून से भी फील नहीं कर सकते हो. Solid in solid is a very very slow process, very slow process. It won't be as fast as this or as fast as what we saw, but you cannot deny कि solid में diffusion नहीं होता है. होता है, solid में भी diffusion होता है, slow. हेडलैम्प्स देखे हैं आपने गाड़ी के? ब्रांड न्यू गाड़ी, एकदम चमचमाती हेडलैम्प ग्लासेस, पुराना होते 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 येलोइश येलोइश हो जाता है ग्लासेस. हैव यू सीन वेरी ओल्ड मोटरसाइकिल? क्या हो गया? स्लो डिफ्यूजन तो होता है. सो मैटर, हाँ,
happen between solids and gas and
yeah, solids and gas. Camphor, naphthalene balls. Best is the urinal, yaar. We keep so much of, what do you keep? Odonil. Example should be like that. Where did the odonil go? Sir, Vakul ate it. Today there was no pickle, so he used odonil along with paratha. Where did the odonil go? It dissolved. So we call that as, what is this process called? Diffusion, but इसको हम कहते हैं sublimation. When a solid changes directly to gas, we also call it sublimation. One fine example. Have you all visited places like supermarket? Again, vegetarians will not know. Non-vegetarians, if you're going to Spar or something like that, you'll see a lot of fish and ice kept. Are they waterized? No. They are all solidified carbon dioxide. Imagine, अगर मछली मार्केट में इतना आइस रहेगा, won't the ice melt? Yes. Then tomorrow when I go to the fish market, I have to take a boat and go, row, row your boat, merrily, 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 because everything should be water. What are those? Those are dry ice. Therefore, next time when you go to a restaurant or some cheap source and you start eating that ice and believing it, please ask, is it water? Because all this New Year party jo hota hai na, half of the ice is all dry CO2, dry ice, CO2. Because itna ice melt hoga to kya hoga? And CO2 is very bad for your throat. Good places will always give you ice which will melt. Ice means ice made of water. The other thing that you're getting is dry ice. Dry ice is CO2. ये जो बड़ा-बड़ा blocks आप देखते हो ना, ठेले में लेके जा रहा है. If you enter any, you must have seen in Kolkata, fish market जाओगे तो ये big block of ice. बड़ा बाजार में तो बड़े common scene है. And with lot of brown granules, these ice are going. What are these ice? These are, ये पानी गिरता है क्या उसमें से? कभी नहीं गिरता है. They just vaporize. And use some common sense. If those ice were made up of water, then the entire shopping mall will become water. Kabhi, have you taken, if you take this water bottle, chilled water, and you keep it on my table, don't you see it gets into water? तो उतना आइस जब मेल्ट करेगा कितना पानी आएगा? ठीक है?
So diffusion happens.
हाँ, so diffusion happens from solid to air also. Camphor being an example, naphthalene balls, you know, which we put in our clothes, and then odonil, you know, one of the very nice example. Plus the AIR, those pouch which we put in our bathrooms nowadays with a hook, and you can hang it. वो क्या हो रहा है? Diffusion ही तो हो रहा है. अच्छा, have you felt that when you put that AIR strip, AER, not AIR, AER, Godrej, those bathroom fresheners, जब आप नया लगाते हो, बाथरूम घुसते ही कितना सुंदर स्मेल आता है. 5 मिनट बाथरूम में रहने के बाद do you anymore diagnose the smell because your nose has now become also high region of concentration. फिर नया कोई घुसता है, आपके बाथरूम में तो बहुत अच्छा स्मेल है. Yes.
Carbon dioxide.
कार्बन डाइऑक्साइड इज अ गैस. किसी भी चीज को प्रेशराइज और एक्सपैंड करने से लिक्विड बना सकते हैं. एवरीथिंग कैन बी रिवर्स्ड. वी सॉलिडिफाई कार्बन डाइऑक्साइड. सॉलिड आने के लिए पहले लिक्विड आना पड़ेगा, उसके बाद ही सॉलिड होगा. बिकॉज उसका लिक्विड स्टेट नहीं है ना, उसको आपने जबरदस्ती किया था. उसको आपने जबरदस्ती किया था. जैसे ही एटमॉस्फेरिक प्रेशर मिल जाता है, दैट इज वेरी हाई प्रेशर फॉर एयर, खुल जाएगा उससे बेसिकली. लिक्विड एंड गैस डेफिनेटली. हैव यू नॉट सीन परफ्यूम्स? वो जो एड आता था, तेरे फॉग में क्या गैस है भर के, या परफ्यूम भी है. So if you are buying good perfumes, what is the difference between a deodorant and a perfume? If you are talking, everything is flammable. Perfume is दो चीजें हैं, 3 चीज मिलते हैं. First is you get a roll-on stick which you can roll on your body. So that is something which is solid, has a rotating solid ball and has a liquid which keeps on supplying to it. The Nivea roll-on. Then next comes is a deo, a cheaper deo. A cheaper deo will basically have a base, which is a base compressed liquid, such that when we press it, what are you doing? The liquid is in a very high compressed state. जैसे you press it, the liquid gets a place to come out. Once it comes out, it immediately becomes gas, just like your LPG. I hope you know the red cylinder in which you cook, that is liquid inside, pressurized hai. So when you press, you actually allow the air to come in contact. High pressure hai, so the liquid does not come out as liquid, the liquid will come out as gas. That process is called as atomization, atomizer. And while coming out, it will come out with that fragrant part. The fragrant part, if you are using a cheap deo, means the fragrant part will be less. इसीलिए बोलते हैं, ए तेरे फॉग में कुछ है भी, ये तो खाली गैस डाल रहा है. Perfume has more of the perfume component and less of the perfume itself is also volatile, which is very costly. So how do we use perfume? Deo is not supposed to be put on your clothes. अगर आप कपड़े पहन के deo लगा रहे हो ना, then you are an idiot. Deo is supposed to be put on your bare body. Perfume can be put on body, skin as well as clothes. And where do we put perfume? Hot zones. Where? Here, behind the ears. These are considered to be warm. So diffusion will take place. And diffusion is directly proportional to temperature. Hotter the, okay, I cooked biryani and I kept it in the refrigerator and I have kept the refrigerated biryani out. Will you smell anything in my house? No. More is the temperature, more is the rate of diffusion. और गैसेस में हाईएस्ट डिफ्यूजन है. इसीलिए एक मिनट आ रहा, इसीलिए परफ्यूम्स जब आप हॉट जोन्स पे लगाते हो, ये टेम्परेचर जहां जहां ज्यादा है आपको रेडिएट करेगा ज्यादा. यस. गैस नहीं, वो हाई प्रेशराइज्ड है. दैट थिंग इज एक्चुअली अ गैस व्हिच हैज बीन प्रेशराइज्ड एंड मेड इनटू लिक्विड. दैट्स व्हाट शी वाज आस्किंग. शी वाज आस्किंग that carbon dioxide is a gas, gas to liquid, liquid to humid solid ice. But when it started melting, why did it become gas only? Its liquid state cannot be seen at the temperature that you have, at the pressure that you have. इस pressure में carbon dioxide को आप liquid देख ही नहीं सकते हैं. What is the pressure? 1 atmosphere around us. It has to be very high pressure when you will see carbon dioxide like a liquid. Have you seen cigarette lighters and other thing where you see the fuel? So you see it what in a liquid state? But once you press that striking stone, it is coming out as gas. And gas is what is burning. Didn't in grade 8 we learned what gives you a flame? Only only fuels which vaporize on burning will give you, सब भूल गए तुम लोग. Flame is the vapor zone of a fuel. कोयला आपको फ्लेम नहीं देता है क्योंकि कोयला गैस होके ही जलता है. पैराफिन आपको फ्लेम देता है क्योंकि पैराफिन है सॉलिड, टेम्परेचर आने पे होता है थोड़ा सा लिक्विड ऊपर और फिर वो वेपोराइज करता है विक में, और विक के चारों. फ्लेम इज द जोन ऑफ द वेपर पोर्शन ऑफ द फ्लूइड. जो चीज वेपोराइज करेगा वही फ्लेम देगा. हाँ, और एक गंदा एक्सपेरिमेंट बता दूं, कभी नहीं करना है, कभी नहीं करना है. आई शुड नॉट इवन टॉक दिस. इफ अ गैस फ्लेम इज ऑन एंड इफ यू प्रेस परफ्यूम, द फ्लेम शार्ट करके तुम्हारे पास आ जाएगा. करना भी नहीं है ये. ओके, इट्स वेरी डेंजरस. सो मैटर, particles of matter are in continuous motion. So we have seen this, and then let us have the third one. There is space between the particles. Wow, उनके बीच में स्पेस होना पड़ेगा. सर आपको ये चीज कैसे पता चला? इसलिए क्योंकि ये था पानी का पार्टिकल्स और हमारे KMnO4 पार्टिकल्स इनके बीच में जाके बैठ गए, वरना जगह कहां से मिलेगा? कैन यू जस्ट स्टेप अ लिटिल बिट ऑन द लेफ्ट, आई वांट टू कम एंड सिट हियर. ऐसे ही जाके बैठ गए, है ना? और यही हम आगे देखेंगे that after some time if you mix sugar in water, see how nice stories come out. Do you know what is a saturated solution? Okay, we say, hey sir, don't teach anymore, my brain is saturated. What does that mean in English? मेरे दिमाग में और नहीं जा रहा है बाबा, I'm full. So when you start mixing sugar in water, after some time no more sugar will dissolve. The sugar will be seen out. So we say what? Saturated solution हो गया है. Then what do we have to do? Just 1 minute. नहीं, don't heat it. देखो example देखो. Then you go to your, all of you have traveled by Indigo and SpiceJet and all. So when the shuttle comes near to the aircraft, what is the tendency of people? All to stand near the door or near the driver. And then you give a superficial feel to the passenger outside, he doesn't board. So get inside, no, it's full, saturated. अब क्या करना पड़ेगा? यहाँ पे शुगर को क्या करना पड़ेगा? दो चीज है. या तो अंदर आके आपको क्या करना पड़ेगा? टेम्परेचर बढ़ाना पड़ेगा. So once you increase the temperature, going by Bhavia's thing, these water particles start gaining energy. यहां आ गया, दूसरा वाटर यहां जा गया. आइए बैठिए. और इंडिगो में क्या होता है? मैम प्लीज गेट इनसाइड. जैसे गेट इनसाइड सर, गेट इनसाइड जैसे से बोल रहा है, वो भी टेम्परेचर ही बढ़ा रहा है ना. हाँ प्लीज प्लीज. जितने लोग बाहर थे सब अंदर आ गए. 2 मिनट पहले लग रहा था कोई भी अंदर नहीं आएगा. Saturated solution, saturation we killed it. How? By just increasing temperature. एक और रास्ता भी है. Add more water. तो क्या होगा? जैसे ही आप ज्यादा वाटर ऐड करोगे, हम नए पार्टिकल्स हमारे बीच में और जगह है. और क्या होगा? चलो मिकी माउस क्लब हाउस इनको ऑक्युपाई करते हैं. क्यों बैठे हो खाली? बजाओ ताली. ये भर गया यहां पे. इसको फिर एयरपोर्ट में जाइए और बस को खींच के और सीट्स कर दीजिए. मोर पार्टिकल्स कैन गेट इन. सो आइदर बाय इंक्रीजिंग द वॉल्यूम, ये और आगे था, बच्ची ने भी छेड़ के रखा था, तुमने भी छेड़ दिया तो यही पढ़ा दिया. आइदर बाय इंक्रीजिंग द वॉल्यूम और बाय इंक्रीजिंग द टेम्परेचर, सोल्यूबिलिटी कैन बी चेंज्ड. नहीं सर मैं इतना ही मिक्स होता हूं. तू हट जा यार. जैसे आपने टेम्परेचर बढ़ाया मिक्स हो गया. Yes, solubility can be decreased. I'm coming to that. 1 minute. I'm coming to that. ये हो गया. And another way you can say, sir, I took a chammach and I started stirring. Stirring कर रहे हो तो क्या हो रहा है? Friction हो रहा है. Friction से temperature will increase. And so the water molecules separate out. Now he says, can solubility be decreased? बढ़िया से example. Few days ago, my mom was not doing well. So I used to give her electrol. तो ऐसे देते इलेक्ट्रॉल कैसे हम देते हैं? जैसे ही पानी लेते हैं, इलेक्ट्रॉल डाल दो, ORS डाल दो, इट इमीडिएटली डिसॉल्व्स. मैंने तो ऐसे ही आया. आई वाज टॉकिंग टू माय डॉटर समथिंग टिपिकली ऑन सॉल्युबिलिटी ओनली, एंड आई सेड चलो लेट्स मेक अम्मा's ORS. सो आई टुक बॉटल एंड आई पुट ORS इन इट. इट डिसॉल्व्ड. आई सेड डोंट गिव इट टू अम्मा, पुट इट इन द रेफ्रिजरेटर. ठंडा कर दिया उसको थोड़ा. ठंडा करते क्रिस्टल नहीं, जितने पार्टिकल्स सॉरी डिसॉल्व किए थे, all the particles started floating up. So after some time, you're seeing what? You're seeing that the electron which was dissolved very nicely, that electron came out. So if you increase temperature and you increase solubility, if you decrease temperature, solubility can be decreased also. So when you make a ORS solution next time, like an idiot, don't use chilled water and make ORS. Chilled water में ORS dissolve नहीं होगा, नीचे जाके बैठा रहेगा.
Your space.
हाँ, because
Wonder.
वो ऐसे जैसे typically girls लोग लेते हैं ना, let's sit very closely, we are all from Glendale, will not allow those Chirek girls to sit in between us. Chirek girls are also saying let's sit very closely, let's not mix with them, we're from Bhatia. Then one teacher comes, hey, you all are all from Hyderabad contingent, separate, mix. So mix away. When we used to go to nationals from our school days, so we used to all go from, we used to have a lot of school feeling, our school together, but we are all representing one zone. Like I was in Northeast, so we were like the East zone. So we don't mix with the Calcutta kids, we don't mix with Guwahati, we are from Dibrugarh, we used to mix with them, we don't mix with others. Then one PT sir came, have you seen Chak De? वहां क्या बोलता है, यहाँ कोई रेलवे से नहीं है, कोई महाराष्ट्र से नहीं है, कोई दिल्ली से नहीं है, you are from bloody the team India. Is that understood? तो पहले सब चिल रहते हैं, जैसे ही डंडा पड़ता है ना डिफ्यूजन हो जाता है. उसी तरह मेरे पढ़ाए हुए चीजें जो आपके दिमाग में जाते नहीं है क्योंकि आप अपना टेम्परेचर डाउन करके रखते हैं, जब मैं पेरेंट्स को मेल लिखता हूं तो पेरेंट्स आपकी आरती उतारते हैं और धीरे से आपका टेम्परेचर बढ़ता है, पार्टिकल सेपरेट एंड डिफ्यूजन टेक्स प्लेस. सब समझ में आ गया. डू यू नो हैना, टुडे टू आई जस्ट एंडेड माय grade 8 class at 6:40. 6:42 2 persons entered my house. इतना पढ़ाई में मन आ गया, मैं तो डर गया, गलत घर पे आ गया. आई वॉज अबाउट टू से भैया मेरा कोई ब्लिंकिट डिलीवरी नहीं है अभी. ओ दे आर माय चिल्ड्रन, दे केम एट 6:40. व्हाई? बिकॉज वीकेंड पे molecules got separated and diffusion took place. Diffusion is directly proportional to temperature. And who gave the temperature? The small mail from the teacher and the danda from the parent. अब लाइफ में भूल सकते हो ये कॉन्सेप्ट? नहीं. और एक पॉइंट और लिखेंगे यहां पे, and that point would be oh wow, yeah. Number 4, there is attraction between the particles. अब ये सर बाकी सब समझ में आ गया, आप ना एक नया नया कुछ डाल देते हो, इसका सबूत कहां है आपके पास? ये एयर है, ये क्या है? वाटर. और ये क्या है? वुड. समझ में आ रहा है? एयर, वाटर, वुड, क्या तीनों मैटर है? तीनों मैटर है. अब तक आप पढ़ चुके हैं मैटर इज कंपोज ऑफ टाइनी पार्टिकल्स. क्या तीनों में टाइनी पार्टिकल्स हैं? अब हम क्या कह रहे हैं? पार्टिकल्स के बीच में ऐसा अट्रैक्शन है, ये बेस्ट फ्रेंड्स ऐसा, बट दिस अट्रैक्शन डिफर्स. क्या हवा के अंदर आप हाथ घुसा सकते हो? ये देखो मैं नागिन डांस कर रहा हूं. तो एयर पार्टिकल्स के बीच में अट्रैक्शन बहुत कम है. क्या पानी के अंदर आप हाथ घुसा सकते हैं? Absolutely, sir. Last time when I was on the toilet seat, I was using my mobile fell down, so I had no other option, so I picked up my mobile. My examples are very harsh, but they make you remember. अब अपना आईफोन तो नहीं छोड़ोगे ना? खुदा करे ऐसा किसी को ना हो, ठीक है? And that too before using the toilet. The mobile went down. So is there attraction between water particles? Yes, but little bit more. Pritisha, when you smile, please smile. Chupa ke mat haso na. Look at her face here. We can give an award, the non-smiling award. Okay, so there is less attraction here. That's why my hands could penetrate. My hands could penetrate here also. That means there is, compared to here, there is more attraction here. तो यहाँ पे हाथ घुसेगा? यहाँ पे हाथ ही नहीं घुसेगा. तो यहां से आगे चल के हम और स्टोरीज लिख सकते हैं, जैसे आपको छोटे छोटे क्वेश्चन देंगे. इज द अट्रैक्शन बिटवीन द पार्टिकल्स मोर इन सॉलिड? ओ यस, आई कैन पुट माय हैंड इनसाइड द वॉल. लिक्विड्स आई कैन, एंड गैसेस आई डोंट सी ओनली.
Measuring to find out the attraction.
Very nice, why not? We just need to take you, hold by your legs and bang your head on the wall. If your head ruptures, that means this wall strength is more. In some other wall, if your head is intact and the wall has broken, we will say TMT Saliya bar. देखिए बकुल से भी नहीं टूटता है. Just that ad comes na, Tiger Shroff comes with one ball nowadays in IPL with Tamanna Bhatia. Instead of them, we will use as our model. So we will be able to get to know strength analysis. Take a drill machine and start drilling. Concrete, when you drill, it makes a lot of noise, so you can get to know. This is what we will study as rigid and fluid later on. Rigid is something that doesn't bend. Glass is very hard. People think glass is not. Glass is hard. Glass से आप nail नहीं घुसा सकते. Glass टूट जाएगा. लेकिन glass में आप ऐसे करके. Wood is not hard. Wood is soft. देखो सुनने में बड़ा opposite लगता है. Wood से nail घुसेगा. Obviously, glass में nail घुसता है. Glass is brittle. That's another thing. Glass cannot take shock. But if you compare between softness and this, then wood is much more soft. Is it clear? Okay, one fine last example and we leave. Which one do you like? The Cadbury silky or the bubbly? Silky. Okay, bubbly. Okay, silky. Refrigerate the Cadbury's Dairy Milk silky for some time so that it has become very hard, very hard. And then people like me who have a craving for sweet, थोड़ा ही खाऊंगा, I tell my wife, थोड़ा दो. उसको तोड़ने की कोशिश करो तो जितना भी आप सिमेट्रिक तोड़ने की कोशिश करो ना, तो ऐसे करके टूटेगा. देखा है कभी? ऐसा क्यों टूटा? शायद यहाँ के पार्टिकल्स तो उसे बहुत जोर से पकड़ के रखा था और दूर के पार्टिकल्स थोड़े कमजोर पड़ गए. But that must be a soft zone. This also proves that whenever something breaks, it doesn't break with a symmetry line. Have you seen? So particles of matter also have this. Now, based on this, from next class, we will be going on these properties and then slowly studying that based on these properties, we'll classify what is the classification that we are going to do. The very first thing, the physical properties of solid liquid gas. हम solid liquid gas पढ़ेंगे, इनके interconversions पढ़ेंगे, some processes पढ़ेंगे, we'll read a little bit about temperature, we'll also read about how to go to US and immediately speak about Fahrenheit and speak about the Indian temperature, that is Celsius, also very quickly, and then slowly we'll close the chapter. अगर आपको मजा है तो हर एपिसोड देखिए.